Okay, so the second section of chapter 4 is exponential functions. The first thing we're going to talk about is just exponents and their properties. So we look at this exponential function. Here it is, f of x equals a raised to the x. So an exponential function is a equation basically that has the variable as an exponent. That's why it's a raised to the x, where a can be any positive integer or negative integer or fraction, so it can really be a can be really any real number, and x is just the variable. So let's look at an example here. So we have two functions here. We have f is x raised, or 3 raised to the x, and g, which is 1/4 raised to the x. We want to find the following for the thousands place. So we want to find g of 3/2, and we want to find f of negative 5/2. So we can go ahead and plug this as our x, 3/2. We're plugging it into g, right? So we plug it into g equation, so there's our x. That x is going to be 3/2. So we have 1/4 raised to 3/2. And remember our our properties of exponents that say, okay, if this is true, when we raise it to a fraction, it's rewriting that as a root, right? So exponents, when exponents are fractions, they are actually types of roots, where the denominator is the index, the type of root, square root, fourth root, so on, and the numerator is the power. And what's underneath, or what's being raised to the base, is our radicand, what goes underneath the radical. So 1/4 goes underneath the radical, and then that would be, I can rewrite it like this. The numerator is the power, so it can be on the outside like that, or it could be the same as square root of 1/4 and the 1/4 cubed, and then square root. So I can cube the 1/4 first and then square root, or I could do the square root of 1/4 and then cube it. This one, be easier, would be just to take, well, I mean, it's the same. It'll get you the same. It will get you the same answer every time. So whichever one makes sense to you, right? This is going to be 1/4 to the third, or 1 to the third over 4 to the third, and then square rooted. This one, I'll take the square root of 1/4, so that's a square root of 1 over the square root of 4, and then cube it. So you'll see that both of these will still be the same answer at the end. Okay, so then square root of 1 is 1, square root of 4 is 2, and then we're going to cube it. And so we get 1/2 times 1/2 times 1/2. That's 1 cubed, which is 1, 2 cubed, which is 8, so 1/8. Same thing here. 1 cubed is 1. 4 cubed is 64, and then we're square rooting that, and we get square root of 1, which is 1, and square root of 64, which is 8. So we can see both ways are the same. So that would be g, or lowercase g, g of x, or not g of x, g of 3/4, right? That's what we put in there? No, 3/2. So g of 3/2 is equal to 1/8. Okay, this one, f, so that means I'm plugging into f, and here's my x, so that x right there is going to be negative 5/2. So you remember the rules of exponents that say when we have a negative as an exponent that we can put that, make it a positive by putting 1 over the top, and now it's 3 to the positive 5/2. So now we have a positive exponent, 1's over top, and now we can rewrite as the radical exponent as or the fraction exponent as a radical. So 1 over root square root, because the denominator is a 2, and then 5 is the power, so I can leave that on the outside. Or, oops, leave that power 5, the numerator, on the outside, and put 3 on the inside. Or, because I don't know the cube root of 3, so I might not want that on the outside, so I might want it on the inside with the 3, because maybe I have that answer better, right? So 3 cubed, 3 times itself 5 times, which I don't know off the top of my head, but that's okay, because 3 to the 5th is 3 5s, right? 5. And then square root means I'm looking for pairs, right? So here's a pair of 3, so 1, 3 comes out. Here's another pair of 3, so that 3 comes out. 3 times 3 is 9. So this is 1 over 9. And then 1, 3 stays in there, so root 3 stays in there. So I have 1 over 9 root 3. Then we can rationalize that by multiplying top and bottom by root 3. So we get root 3 over 27, because here again we have another pair, so that's another 3. And so that would be my final answer there. Alright, so that's kind of how you do these ones. So you kind of follow those rules of exponents, right? Rules of exponents. And here are some properties of exponents as well. When we have in this form, that's the exponential form, where a is a real number and x is our variable. And we can do all real numbers for x as well. Here's a property. If I have some number raised to a variable, and I have that same number raised to a different variable, if my bases are the same, my exponents have to be the same. Okay, so for example, if I have 3, 2x minus 1 equals 3x plus 4, since my bases are the same, that means my exponents have to be the same. So that means that 2x minus 1 has to equal x plus 4. And now I could solve this for x. Subtract 4 on both sides, or add 1 on both sides and subtract x. Alright, so then we have x equals 5. So x equals 5 would make that statement true. So that's one big property. If the bases are the same, that means the exponents have to be the same. Okay, so let me do the homework problems for these, and then that's pretty much it for this this concept of section 2. Okay, so here are properties of exponents, page 409, number 3, 9, and 13. So it's kind of like the example we just did. Even the equation is the exact same. So we want to find f of negative 2. So we plug in negative 2 in for x. And whenever we have a negative exponent, we use those rules of exponents that say we can put a 1 on top, bring it down to the bottom, make it positive, and 1 to the third. 1 over 3 squared is 1 over 9. So there's the answer for that. Now 3 halves. We did the one with, did we just do this one? So we did this one already. So it's already done for you. So this is the square root of 3 cubed. Or never mind, I guess we did it in G. We did 3 halves into G. Now we're doing 3 halves into F. So it's the square root of 3, and my numerator is my exponent. It is the power. Okay, so I can do the square root of 3 and then cube it, or I can cube 3 and then square it. Well, I don't know what the square root of 3 is. I know that it would be the square root of 27 here if I do 3 raised to the 3 first. But remember, 3 to the third means I have 3 3's, and square root means I'm looking for pairs. So look, there's a pair, so I take a 3 out, and I have that 3 remaining. So 3 root 3 would be the answer. Here I'm plugging in 2.34, so 3 raised to the 2.34. That you're just going to have to do on a calculator. So you take 3, I'll show you how you can do that. All right, so you type in 3. On some calculators, it has X with a bar on it, the ones that I have in my classroom. If you have a different one, you can use this kind of hat button, and then you can do and then you can just type in 2.34. So either way would work. And so you raise it to 3 raised to the 2.34. Press enter, and you get 13. So f of 2.34 is equal to 13 nearest thousandths, tenths, hundredths, thousandths. Okay, so there's your answer for number 13. Okay, so there you go, all done. That's it for that concept.